synchronized. So I'm doing circuits, apparently. I guess that makes sense, because I have to do the circuits before the circuits do me. In this case, what the motivation is that I've been going through all of my various stuff. I have to be quiet, because it's like midnight. Too bad I'm building an audio amplifier again. Oh. This is the audio amplifier I made before. It's meant to be a guitar amplifier. See? It has holes. 1, it's heavy. 2, I've used it like twice since I invented it. It doesn't work very well because it just makes a really bad sound, and you have to press a button repeatedly to make it work. I do not know why. I do not know the principles by which it works. I remember I showed the schematic to an electrical engineer. He was very displeased. He's like, "Why have you not biased the amplifier?" And I'm like, "I don't know what that means." Because actually, I don't know how to do any of this. I know like 3 things electrical. It just works. My essential electric seal here is basically the same level as a Warhammer 40k orc. It runs entirely on belief, but it actually does work in this case. So let me see if I can get you an idea of what I'm trying to do. So, thoughts all over the place. I need more coffee to focus. Actually, orange juice. Because orange juice will help you concentrate. The point is, I have guitar amplifiers. They work. So why do I need this thing to be a poorer version of that? But then I realized, well, there's a type of amplifier I don't have that I do need. This thing takes up space, so I'm going to tear it apart and rebuild it into 2 different circuits, the main one being a new amplifier. The new amplifier is designed specifically for multi-vibrator instruments. I know what you're thinking, but an astable multi-vibrator is actually quite a useful instrument, even though it produces a grotesque square wave. Although you could probably filter that to a sine wave. And yes, it is called a multi-vibrator. There's also a monostable multi-vibrator, which is something completely different, which I'll probably do another video on, because this entire circuit actually turns out to be 90% similar to how you would build a robot. I just realized it the other day. It's like, wait, this is a robot circuit. Why am I using this as a guitar amp? Turns out a guitar amp and a robot are like 90% similar. It's just switching the astable multivibrator to a monostable multivibrator, and this particular amplifier circuit here is actually also a good motor control circuit. But I'm getting ahead of myself, but I don't care anymore. So the multivibrator produces a 6 to 9 volt output. That's not great for a guitar amp. A guitar amp is designed to take a little coil and hear the tiny difference in the coil and amplify that. So yes, I can feed 9 volts into it and make a sound come out. It's not great for the circuit though, and you have to turn the volume way down. I'd rather have a dedicated multivibrator amp, which also changes the way it works, because I don't actually need an amplifier circuit. Sort of. I don't need an audio amplifier to take tiny sound, because the sound is already an audible level. I just need to make the audible level diode powering, that's like a 1.2239 volts. I just need to make that loud. So that's very easy. I can figure that out, I hope. I was going to clean off my desk to demonstrate what I'm doing, but I figured this is actually more informative. Mostly. Doesn't look like anything, because half the stuff, there's a fan because it's hot. That's the prototype of what it looks like, and anyone who knows anything can look at that and tell you that... Can I draw this? I probably can. You know what? I think I'll do one better. I think I'll do an animation, which is actually what my main channel does. This channel is the alternate one now. This switched each other. This is an H-bridge, so I'm going to explain what an H-bridge looks like, and you're going to not see me, because I'm going to have to sit down and draw an animation. An H-bridge consists of 4 transistors. So in those transistors, they're you can think of them as diagonal. They don't have to be, but there's diagonal ones that are PNP and NPN, meaning that when you introduce a base current, the bases are usually connected in an H-bridge. When you introduce a negative base current, it produces 2 diagonal transistors and runs the electricity through the central connection point in one direction. When you then fire a P instead, it fires the other 2 transistors, and the current flows the other way. That produces... So if you were to send an oscillated wave through that is positive and negative, it would be AC, except it's not. It's DC moving in two directions, not AC. There's engineering parameters beyond that that are beyond me. I don't understand, because functionally, from the perspective of whatever you put there, it would be AC. It's not AC. Interestingly, the output of a multivibrator is not... This is something that confused me a lot as a kid. The multivibrator output is not positive. It's positive negative, because this is... So it's digital. And it turns out digital isn't ones and zeros. They say it's ones and zeros, but 0 is actually -1, because it's not float, it's 1, which is positive, or -1, which is negative, which turns on and off transistors. If you let it float at 0, there's no current. 99% or 90%, a lot of transistors will just consider that an off and just turn off. There's a very small number that will either consider that an on and not turn off until you hit it with the opposite current, or voltage. I think transistors use current and MOSFETs use voltage. There's a very small number that just sort of float between the two if you don't connect it. What this one does is it's forcing positive and negative, but the output of the 555 is not AC. It's like if I had a wire. I have a lot of wire, but they're all connected to delicate things. Oh, wait. If you imagine that's the output, that actually hurts quite a bit. It's as if I'm taking this positive, negative, positive, negative, positive, negative, positive, negative. I think that's what a 555 basically does on its output. That's not AC, because if this is on negative, then I would be experiencing circuitry on only half of it. It has to switch the other way. But it works with transistors because there's a positive trigger and a negative trigger. So it makes the H-bridge pull in opposite directions, which can... Oh, that's going to get infected. Good thing I'm immortal. On a speaker, if you just do on-off, it just goes ba-dum, ba-dum, ba-dum. If you do it both directions, it goes boom, 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 boom. So it's louder. The transistors I used here are also Darlington-based, which means I can... It's complicated, and it doesn't really matter in this context. So what I have right here is on this circuit, this is a substitute instrument. Rather than get out an instrument, this didn't work, so that can come off. That can't, though. That one needs to be connected to pin 3. If you're wondering what the circuit looks like, this is a saw, and nothing to do with what I'm doing right now. That's what it looks like. Oh, it wasn't up long enough for you to see it. There's a thing on these YouTube videos called pause. Also, it's one of the simplest and most fundamental circuits of electronics. Instead of using the whole instrument system, I built just a little miniature one, and I can demonstrate how the miniature one works by connecting a speaker directly to it, because the 555 output is strong enough to drive a small speaker. So, speaker goes to pin 3 and positive. I connected some batteries to a little port, so all I have to do is... That's a speaker being driven directly through the 555, so no amplification additional. But also, it can't actually handle a huge amount of current or voltage, just a little bit. The idea is to have that power a transistor, and it's a very simple thing. I think most of my circuits actually do have a transistor just because. In this case, then, I'm taking that from this pseudo-instrument. This is the part that will be the instrument part. And here is where I ran into a bit of a problem. So my original intention was to have a totally electrically isolated circuit, to which I have this, which is an opto-isolator. And those of you who know what an opto-isolator means, you're saying, what did you just pick up? That's not an opto-isolator. An opto-isolator is a 6-pin IC, barely the size of a dime. I don't have any of those, so I made one from LEDs and phototransistors, and it didn't work. So it goes over here. The idea was to use an opto-isolator, which has an LED triggering a photosensor that then sends a signal through light to the other circuit, meaning that the circuit doesn't have to communicate directly. Part of that is just the issue that in a guitar, it's a coil that generates its own electricity that feeds into the amplifier. The guitar is usually passive. It doesn't have a circuit leading to it. In this case, the instrument has a battery. That's one circuit. This has a wall plug. It's a different circuit. How do you make two circuits communicate with each other? It sounds superficial when you say it like that, but it's very confusing how you would actually accomplish it. There's going to be a transformer too, which is that, but I didn't use it, so that also goes down here. Right now, the prototype as it sits instead works on the principle of sharing a common ground. So there is this wire. It connects this circuit to this circuit. That means that this circuit runs on 6 volts. This circuit runs on some other voltage, whether it's 9 or 12. And never the twain shall meet. They share a ground, and they share a positive, but only through the transistor. So it's just ground connected. This circuit never feels the voltage over here, and the two operate independently. I don't know how that works. I think that was one of those random thoughts where like you start to fall asleep and you're like, common ground. I don't know how that works, but it does. So what that means is that if I were to connect, so the first example of this, I will connect, so in this instance, I have now connected a speaker to the output of this H bridge. Yes, it's made of wood. I screwed the transistors onto it and hot glued them, because why not? Who cares? Nobody's going to see it except me and you. This connects to 6 volts and should turn on. I have to connect this, that's pin 3, the output, to this. This is the H bridge's input. I don't know if you can hear that, but it makes a sound, and I don't know why. I don't know how it's communicating that. I think just because the circuit is somehow... Well, okay, basically what it's doing is that bipolar transistors have some current flow between the base and something else in them, so it is actually drawing power from here and pushing it through the speaker at a small level. Probably should have used MOSFETs because they don't do that. It's not called a base, but the base of the MOSFET, electrical engineers just exploded out there, isn't conductive, so it doesn't do this. This is just a bipolar transistor problem. But this is a 9-volt battery that represents what would be a wall-based 12-volt DC supply or something similar. Connecting that in, it now is much louder. Of course, that does let you say, well, hold on a second. That circuit doesn't make any sense. You're just taking basically the positive output of that thing and running it through here. Is it actually H-bridging, or is it just activating one set of transistors repeatedly while the other half just doesn't turn on? In other words, are we experiencing just up peaks or up and down peaks? The way I determine that, take the speaker out, is to connect a pair of LEDs. LEDs only conduct in one direction. They're a diode. That's what the light-emitting diode. A diode only conducts, unless it's a Zener, but the diode only conducts in one direction. So, if I then connect it to circuitry, it will not make sound. Figured it out. Those are very close to each other. They, and that's called a short. I forgot there's a light over there. Well, okay, I now can't see the backside of a diddly squat. And I'm now touching electricity in the dark. I don't know what your resolution is, but there's 2 lights there. There's a third light. What's the third light? Why is there a third light? I guess that's just a reflection somewhere, I hope. Maybe? What is that? Don't know. But there's two lights. That's a simple test. What does two lights mean? Two lights is a good thing. 18 minutes. How long have I been talking that this is 18 minutes long? Two lights indicates that the circuit does work. It's producing current that goes in one direction and then the other direction. One direction and the other direction. And that makes one LED turn on and then the other LED turn on. They're at a high enough frequency that they look like they're simultaneous, just because it's that clicking. Meaning that this actually does drive circuitry in both directions. It also means, therefore, that it's a standard push-pull that can draw from a 555 astable multivibrator. It takes with two cables, which just means that whatever comes through has to be, I'll have to look at my designs to make sure that it's always putting, I'm sure there's a technical reason that the same thing should always be ground on the port, but I think I just did them randomly, so I have to make sure that the same one is always negative, because it'll feed two wires. It'll feed the common negative, the ground, and the feeder. I don't think I can mix those up, or it won't work. It might even explode. I hope it doesn't. The point being, as cool as this is, as cool as this was, as fun and frustrating as it was to build, it takes up a lot of space and isn't being used. This is the last time you'll see it. I'll be taking it apart, recycling the materials, siphoning off there's two circuits, because I do want the amplifier circuit for another project down the line. So mainly I'm going to take this speaker and the control circuits for it and connect it to this new amp instead and rebuild a better version. So I'm going to do that off camera because it's going to take me a long time, and because I have to do it probably tomorrow because it's midnight right now and I don't want to be operating power drill. I do very, very much want to be operating power drill at midnight, but there's people sleeping on the other side of that wall. I think I haven't checked.
Well, I built this apparently. This is what the circuit looks like inside of the old amp. I don't know what any of this is. Like, what is that? What is that? Why is it? Where do these go? Why is... and what is... That's a regulator, actually. That's valuable. Oh, look! Light bulb used as a resistor. I clearly won't do that again. But I actually do kind of need this. That's how the power works. It's a power supply plugged into a thing that's plugged into the cord. It leads out. That's the amplifier circuit. So I'm going to try to salvage that. And get this thing out of here. I guess. Probably?
That's how I sneeze. It's how I've always sneezed. It's up to 12 is normal. I have a window open to let the effluvium out and the pollen is getting in. I need to take some allergy medicine, but after I demonstrate that this actually surprisingly worked-ish. So, one, you can see that's the speaker. It's now sideways. So this is itself the new amp. Now, you're going to ask yourself, what am I putting my hands on right now? The answer is the pot that I used to make my pasta in. It had a fracture in the bottom, and the coffee, I used to make coffee in this, the coffee was leaking out. So that wasn't viable. I have a coffee machine now. We'll get to that later because I have to do some work on it. I can't weld. So the crack turned into a hole, and now it's a hole full of pieces of molten glass, because apparently welding metal back together with glass works about as well as you'd expect, which is not at all. So don't look at the butt. Well, you're going to have to for this next part. So the actual circuitry of this device is in the can. There is a hole in there. It's right about there. That a big wire comes out that has 3 inputs. Why is that not? There it goes. 3 inputs. So the actual circuitry takes positive from the power supply, ground from the power supply, and also to the central or outer line of these connectors. I have to unify that because ground on this has to be the outside one. If not, something bad will happen, but I don't know what. So that's just my design, how I build my instruments. I have to make sure that the outer connection is it's very visible on these. The outer connection is always ground. Outer connection goes to ground. It's a common ground between 2 separate circuits, and the base connection is the other side of this. It's a mono channel. See, it looks like that. So I guess you'd say that one turns into ground, and that one is maybe. I don't think it actually works that way, but one of them's ground, one of them's signal, and it's always the same because that's how I have to build it. Only 3 wires go in, and sound comes out the other end. This down here is the power panel, which is on the back. Usually it's on the front of amp, but the amp overhangs itself, so it doesn't fit that way. I did modify it so that the other amp had a power cord, as I'll show you the video. The other amp has a power cord that leads to an outlet inside the amp that then one of these plugs into, and I was starting to do that, and I'm like, do I really want to put 120 volts in an opaque metal can where it could potentially short circuit? And I'm like, well, wait a second, this is a power supply. Like, I can just plug it into the wall and instead use a port for this. Like, even advantageous more is this is voltage agnostic. It doesn't care what voltage you put into it. The circuit runs regardless. I've run it with 9 volts, you can run it with 12 volts, 5 volts is just fine. In theory, 20 would work. I think it goes up to like 60 for these transistors. I mean, in theory, because I put an indicator light on it, you shouldn't go above like 15. So it plugs in. See, nice. This goes to the outlet behind me. It has. So it works. You're gonna have to take my word on it. I will show you in a second. But there's a big but. It heats up a lot. And I don't know why, because I don't want to think why, because the entirety of the circuit is sealed inside a peanut butter jar in here. And I don't want to open it again, because this is like tied on with wire. I think it's that it funnels a lot of power through itself. My hair is flat on one side, but I don't know which side, because like I'm like, oh, it's not a mirror. The screen is not a mirror, it moves opposite, so I can actually see myself. Can't see you. I totally can't see you through your computer. But anyway, it has to be plugged into actually something in order to not like short circuit. So I did put in a 15 watt resistor. It's right behind here that just protects the whole thing, so literally it can't overheat at 12 volts. Mostly. Technically, I did the calculation and it can't fry itself at 15 ohms, but I didn't have a 15 ohm resistor, so I used 5, and I'm guessing the internal resistance of the circuit is fine. So, for the first demonstration, we'll use this. Again, I have connected the innermost connector to ground, and the outermost connector to positive? No, to pin 3. Pin 3 is what I'm connecting to. I have to think about it for a second. So, I don't know if you can hear that. It's just a weird feature of this circuit is that because it shares a common ground and because these are bipolar transistors, like I said before, the power is actually flowing through the transistor and powering the circuit. So, like, this 6 volts is actually making this big speaker run, because it's only an 8 ohm speaker, it'll still make sound. I think it's actually 35 ohms, which probably explains why it's not burning up, is because the speaker is acting as a resistor. I did also put the light bulb in just because I thought it was funny. It's like 2 or 3 ohms. I don't know how light bulbs work, how their resistance changes, but I think the resistance when it's on is different than the resistance when it's off. Anyway, there is a power switch here. So that actually connects this circuit into it. I added a volume knob, which is a stick on a potentiometer. I drilled a hole in a thin stick. I probably should have used a thicker stick, but the stick works just fine. It's not a very, so I'm going to go up, and so that's the test circuit. So actually what happens is if I disconnect that, see, that blinking is the power supply frying. It's not, you know what it is it's probably just going through the audio connector back to itself. It has a short protector, so when it senses a high current, it cuts, which basically makes a neat little square wave generator that you should never use. Kind of like how if you connect a relay and it's paradox formation, it buzzes, but it burns up the relay pretty quickly. This wasn't designed to run this circuit. It was designed to run one of several circuits, which, if you actually have been paying attention, you know I don't normally have that rod behind me. That's not a rod. That is a musical instrument that I built probably 15 years ago. It is very simple, but very effective. And this is one of the things that I did want to have this amp to use. I've usually been using this for a guitar. What it is very simply that in the middle, when I still use these circuit boards, I need to tighten it slightly, held in by wood screws, is this. It's one of these with a higher frequency mode. And it has an output put through this. So all I need to do is connect that. Now in a guitar is a passive circuit usually. There's active pickups, but I don't know what that means. You pull a string, it generates current because the string is moving over a magnet, and that produces current that the audio amp picks up. Doesn't work here. This is an active circuit. It requires a battery. It's designed to fit 9 volts. So I'm going to hold it here. It's normally meant to be held kind of like a guitar. I seem squinty because the camera is higher, like it's up there, and I'm looking at my screen. So if I switch this on, without powering on the circuit, I'm going to turn it towards you so you can hear it better. So I didn't actually turn the amp on for that. That was just this battery powering that thing, which is fine. That actually is nice that it has that feature, I guess. It's totally a feature, not a bug. Just to explain how this circuit works is the 555 timer astable multi-vibrator is at a very, very tiny capacitance. So it means that a very large resistance can produce a tone. My body has resistance. These two pieces, this rod and this little pad, are poles. By touching it, I send the electric current through my body, and by increasing the pressure, I can change my resistance and change the output frequency, making a tone. Now, first of all, I'm going to use, weirdly, when I grab this, it makes sound even though I'm not connected. I think it's because I'm acting as an antenna. I'm going to tune that down so that this doesn't deafen everyone in the area. Now I can tune it up. So the idea is just don't hold on to this rod and I'm just messing around at this point. So the resistor in there does, I should unplug it before I stick my hand in the back circuitry. There's not 120 volts, but whoo, yeah, that's getting hot. But I don't expect this thing to, this isn't designed to go through a concert. Forgot it did that. It's not designed to go through a concert. It's for making short sound effects or components of a song, as long as it can stay stable for up to 5 minutes of use without actually lighting on fire, it's fine. I'm just not selling these things. I can't sue myself. You know, it would actually set an interesting legal precedent, but I think any judge would literally grab me by my 2 sets of lapels and throw me out of the courtroom. This amp serves a very particular purpose. This will not work with a guitar, I don't think. I don't want to try it because it probably puts too much current through the guitar to begin with. Maybe in the future once I actually build a test guitar, but that is a long way off. So the old amp didn't work very well because it was designed for a purpose it couldn't really serve. This one works, and I'm not 100% sure why, other than that it gets hot, which we can just totally ignore that that's something it does. It's fine. It works great. Sounds good. Made of a pot and like a $20 speaker I got off Amazon, and wood that was heavily waterlogged, and screws. And a Christmas light is the indicator light. So lots of stuff that was just around, and it seems to work perfectly fine, I think. So I consider it a success.